So in our last video, we learned what the definition of conditional probability was, and we learned how we can more or less think about certain questions and just get the answer for our conditional probability. There is a formula for conditional probability that I'm not going to go into, like I said in the last video, in Algebra 2. It can make the problems, you can answer tougher problems with it, but at the same time it can be a little bit more confusing and we don't have the time to go into it right now. So these probability questions, again, if it's conditional probability, in my class for my test, you will need to basically be able to analyze the problem and come up with a solution. You don't have to worry about a formula. So anyway, oftentimes you'll be given a table of data and asked to analyze it to kind of see what's going on. So, okay, we have 200 people here, and they're broken down into whether they're male or female, and whether they preferred a cat or a dog. So if you add up all these numbers here, they're going to be 200 people altogether. 48 people who were males who liked cats, 57 were females who liked cats, 40 males and dogs, 55 females and dogs. So it's just broken down by, I don't know, well, they did 4 different categories right there. So our first problem asks us to consider the probability that if you pick somebody at random, they're going to prefer cats. Well, there are 200 people here, so that's fine. It's out of 200. For my top number, I need to figure out everybody who likes cats. The people who likes cats are these ones and these ones over here. So I'm going to add those together, and I'll put that number over here just so we can see it. There are 105 people, 48 plus 57, who prefer cats. So we're looking at 108 out of 200, which if you divide that out is going to be 0.54. There's a 54% chance if you pick somebody out of this survey, they're going to prefer cats. Similarly, if you want to find the probability of somebody being female, you need to look at these females who like cats and the females who like dogs. So when we add this time, we're going to add these two numbers together. 57 and 55 is going to make 112 out of 200. And 112 out of 200 is going to be a 0.61 for our probability here. So when it's just a straight up, let's see, I feel like I might have messed up on my probabilities. Let me check those real fast. Blanking on my division for some reason. Yeah, this one over here, I'm sorry. This is 0.56 right here. I knew that didn't look right. All right, sorry. So we had a 0.56 for this probability, and we have a 0.54 for that one. So when we're looking at just a basic probability here, not too bad. You just add them up and you're good to go. It gets maybe slightly tougher when you're doing conditional probability, though. So the first one asks for the probability that you are male, given that you prefer dog. We already know that you prefer dogs. We want to find the probability you're male. Well, if we know for sure that you prefer dogs, we don't care about this top row of people up here who like cats. All we care about are the dog people right here. If it's given that you prefer dogs, we know it's not one of these people up here. So I'm actually going to cover that up with my hand right here. I'm only looking at the bottom ones. 40 and 55 means now I only have 95 people that I really care about because I know they prefer a dog. I want to find the probability they're male. Well, the males are right here. There are 40 out of those 95 people that are male. So my probability for this one, the bottom number changed because I was told already that they prefer dogs. And if you divide that out, you're going to get 0.421 roughly for our probability. On the next one here, it says find the probability you prefer cats given that you're male. If we know you're male, that means we know you're either here or you're here. The male is what's given. So in this problem, we don't care about the females that are taking our survey right now because we already know our person's going to be male. So that part of the table right there really doesn't interest us. All we care about is this part right here. So we're only looking at 48 plus 40 is 88 people. So this probability is going to be out of 88 because there's only 88 males here. And the ones who prefer cats are these guys up here. So it's going to be 48 out of the 88 people, which if you divide that out is 0.54 repeating. So we got about a 54% chance, 5454, etc., of getting that to happen. I have a second table here, with just a little more practice on these, because these do give kids a little bit of trouble. It just takes a couple examples and you'll get it down, but I want to make sure the practice is there. So we're looking at a recycling plant right here, and just broken down in tons. So we're weighing it on whether it's recyclable or non-recyclable, and what type of material it actually was. So we have glass, paper, plastic, and metal. This table's a little bigger than our last one. in a problem like this where our numbers are not as pleasant looking, it's okay, you still do it the same way. You should go ahead and just add them up going across and figure out what you're working with first. So what I did is I added these four numbers on the top row. Those made a 120.3. And when I add the bottom row right here, I ended up with 79.7. Now this is actually something that's kind of weird. I felt like I'd leave it in the video and share it with you guys, but I made these numbers off just blindly off the top of my head, like I was just filling in random things. If you add those up, they do equal 200. So I thought it was a little crazy that when I did this second problem here, they equaled 200 as well. But that's just the way things worked out. So again, we're looking at the probability for the first one that it's not recycled. When I write down these numbers here on the end, it makes it a lot easier to see. Not recycled is going to be 79.7 out of everything together. And if you add up the whole table, again, you do get 200 here. That's just by chance. That's the way the problem worked out. So we're looking at 79.7 out of 200. And for these problems, honestly, I know you guys can divide these in your calculator and get decimals. I'm just going to leave it like that for now. For my next one here, I want to find the probability that it's plastic given it's recycled. So I know for sure it's recycled. That means this whole bottom row right here, the non-recycled stuff, doesn't matter to me. I'm only looking at the top. Well, I want the probability, what did I say? Plastic? The plastic is going to be this guy right here, because I know it's recycled. So it's 64.8 out of that whole row, 120.3. So it's 64.8 out of 120.3, and of course you can divide that out to get your final answer. On my next one here, I want to find the probability it's not recycled, given that it's paper. So I know this problem is paper. That means these other columns here, my glass, plastic, metal, those don't matter to me. I'm only looking at those two numbers that aren't covered up right there, the 22 and the 17.8. Well, if we add those together, we could get the same thing going on where we add them vertically. That's going to be 39.8 on this one. That's my denominator, because that's all the paper. And my top, not recycled, is the 17.8. So I'm looking at 17.8 out of 39.8. For my final problem here, I want to find the probability it is recycled, given that it's metal. Again, if I know it's metal, I don't care about the rest of that table. I'm only looking at this part right here. If you add those together, it looks like we're going to get 32.6. So it's out of 32.6. The probability it is recycled is going to be 15.1 out of 32.6. So if you kind of cover up the parts of the table that you don't want, it makes it a lot easier to calculate your probability.